the third way we're going to look at graphing linear equations is in standard form. So we've looked at slope-intercept form, point-slope form, and standard form. All right, maybe. There we go. So standard form is that ax plus by equals c. Okay, so ax plus by equals c. A is always in front of the x every time, and b is always in front of the y. Then c is over there by itself, the constant on the other side. All right, so all standard form is you put x and y on the same side. You put the x first, then the y, and you set it equal to the constant. Right, but two restrictions. A has to be positive. Doesn't matter if B and C are, but A must be positive, and there can't be any fractions. A, B, or C, they all have to be whole numbers. All right, to graphs in standard form, you find your intercepts, and finding the slope, we're going to figure out right now. If I have AX plus BY equals C, we're just going to leave it with all variables right now. Slope-intercept form is a pretty easy way to find slope, and that's when y is by itself. So I'm going to start by subtracting ax. So then we've got by equals negative ax plus c. It's almost slope-intercept form, but I've got to get rid of this b. So that goes away. So then I get y equals negative a over b times x plus c over b. So my slope, if you ever have to find the slope in standard form, you can first put it in slope-intercept form if you want, or you could just plug in negative a over b, and it'll work every time. Okay, so the slope is negative a over b. All right, now finding intercepts. Remember, if I plug in and I have a y-intercept, like if my y-intercept is 4, it would look like 0, 4, and my x would always be 0. If it were the x-intercept, 3, it would be 3, 0, and my y would always be 0. So to find the intercepts, all I'm doing is plugging in 0 for x to find the y, and then plugging in 0 for y to find the x. We also call this the cover-up method, which we'll look at now. So I want to graph 2x plus 3y equals 6. So all I'm going to do is find my x and my y-intercept. So I'm going to plug in, if I plug in 0 for x, 0 times anything is 0. So that whole thing goes away. So I can cover up my x. Well, whenever I cover up my x, I end up with 3y equals 6. Well, 3 times 2 equals 6. So my y-intercept is at 2. Then when I want to find the x-intercept, I'm going to plug in 0 for y, which makes that go away, and I'm left with 2x equals 6, or x equals 3. So I'm going to go to my graph. I'm going to go to my y-intercept at 0, 2, my x-intercept at 3, 0, and all I need is 2 points to be able to draw a line. And there's my line. For the second one, switch colors. If I want to find my y-intercept, I'm going to cover up my x. So I get negative 3y equals 15, or y equals negative 5. To find my x-intercept, cover up y. 5x equals 15, x equals 3. So I'll go to my graph, to negative 5 on the y-axis, and positive 3 on the x-axis. All I need are 2 points, and I can graph my line. Graphing in standard form can be very simple if you just find your intercepts. You also have the option, just like with point-slope form, of moving it to slope-intercept form and then graphing from there, because slope-intercept form is very straightforward as well. Or standard form, just find your intercepts, and that's all you need. Writing equations in standard form. Remember, I have to have x and y on the same side. Put the x first. A must be positive, and there can't be any fractions. So I want to move this 2x over, so I'm going to subtract 2x from both sides. So then I'm going to put the x first. So I have negative 2x plus y equals negative 1. I have no fractions, so I'm good there, but my a is negative. Right now it's a negative 2. So the way I'm going to get rid of that is just multiplying everything on both sides by a negative 1. Just change the sign. Remember, you can do something to your equation and keep it the same equation as long as you do it to every single term. So negative 1 times negative 2x becomes positive 2x. Negative 1 times y, and negative 1 times negative 1 is positive 1. And now we're in standard form. Okay, over here I've got to get x and y on the same side. So I'm just going to move the 2/3 y over. So I've got 2x minus 2/3 y plus 1 equals negative 4. I don't want any constants over there, so I'm going to move the 1, so I'm going to subtract it. 2x minus 2/3 y equals negative 5. Well, my a is positive, but I've got this fraction in here. So the easiest way to get rid of this fraction is just to multiply everything by the denominator. I don't want to multiply by the reciprocal, because then 5 times 2 or 5 times 3 over 2 is 15 over 2, and I've still got a fraction. So I'm just going to multiply everything by whatever my denominator is, which is 3. 3 times 2x is 6x. 3 times negative 2/3, all that's going to do is cancel it out. So I end up with a negative 2y. And 3 times negative 5 is negative 15.
Good.